G'day guys, Troy here from Corsaire Helicopter Flight Training, back at our R22 here today. We're going to have a bit of discussion about the clutch assembly that's fitted to this aircraft. I guess the first question would be, why does a helicopter require a clutch? If we look at our main rotor and main rotor transmission and drive, it's quite a heavy assembly. If we were to try and start our engine with the weight of that attached, we wouldn't have the power to be able to crank the engine over and actually start it. So what we do is fit a clutch assembly to the helicopter to gradually take up the load of our main rotor transmission. So the components that we'll talk about today are in the back of our helicopter here, just behind our main rotor transmission. We've got our two V-belts, our rubber V-belts. We have two sheave assemblies, an upper and lower sheave assembly, and a clutch actuator. So the pilot operated switch in the cockpit, the clutch switch, as we hit that, provides energy to our actuator, which gradually tensions these two V-belts and will gradually take up the load of the main rotor transmission by pushing our upper sheave up and slowly tensioning our V-belts. Here in the cockpit of our R22, I'm just going to point out the clutch switch that we have on our center console assembly. So as we start the engine and we start to stabilise our engine RPM, we engage our clutch assembly, which is behind this guarded switch. As we engage the clutch, we'll get an indication that the clutch is tensioning with our clutch light. All right, back here at the rear of the helicopter, you can now hear the clutch actuator tensioning our V-belts, which would provide drive to our upper sheave. There you can hear the actuator disengage, and we're going to take a look at the workbench with our clutch actuator as to how that actually happens. Now I've got a clutch actuator assembly, so some basic components. We've got our clutch actuator motor and our leaf packs down here, which we're going to talk about now. So as we tension our drive system, we don't want to over tension it, and that's felt or sensed by our leaf springs and micro switches here on our clutch actuator. So as we tension our V-belts, the upper sheave raises. These two leaf packs sense a compressive load and will spring out and push down on our two micro switches, which will cut the power to our clutch motor. So here we have our upper sheave assembly and our lower sheave assembly. So hard mounted to our engine are the lower sheave, and our upper sheaves on the top side of the actuator where we were looking at before. Now this is a cross section of a V-belt. If you zoom in there and have a quick look at that, this is quite a robust rubber material. It slots directly over our sheave, and the second one will go along there. Now this is only a portion of our V-belt. Normally it's a complete loop. So as we tension our clutch, our upper sheave assembly will move up, tensioning our drive belts and transmitting the drive to our main rotor system. Now you can hear the clutch motor actuating in the background there as I've got the clutch switch engaged. So we're mindful as pilots that these belts will retension, and we will get an indication of that with our clutch light. If that period exceeds 10 seconds, we have to pull the clutch circuit breaker, which removes the power to our clutch motor and also the power to our indication for our clutch. So if I come down here and pull the circuit breaker, the clutch actuator motor stops and the power to our indication is removed.